students, this is Ms. Johnson with 9-7 Growth and Decay. Today we're going to learn how to use real-world formulas. Alright, let's talk about a few vocabulary words here. Exponential growth. Exponential growth has the equation y equals a times the quantity of 1 plus r to the t. And a represents the starting amount, r is the rate, and t represents the time in years. Okay, that is growth. Exponential decay is almost the exact same equation, except it is decaying, so it's going down. So instead of 1 plus r, we've got 1 minus r. And compound interest, used so frequently with money, has the formula a equals p times the quantity of 1 plus r divided by n to the exponent of nt. And p stands for the principal, or the starting amount, r is the rate, n is the number of times that the money or interest compounds every year, and t again is the time in years. Alright, example number 1. A college's tuition has risen 5% each year since the year 2000. And if the tuition in 2000 was $10,850, we want to write an equation for the amount of the tuition t years after 2000. And we want to predict the cost of the tuition now. Alright, well right now we are working with exponential growth, and we know it's exponential because it's working with 5%. It's a percentage, and we know it's growing because it says risen. So we're going to use the formula y equals a times the quantity of 1 plus r to the t. Well, let's figure out what our variables represent. A equals the amount of money, and that's $10,850. R is the rate, which it says 5%, and we want to write this as a decimal, so 0.05. And t is the amount of time in years, and right now it's 2013, so this started in the year 2000, so it has been 13 years, so that will represent our t. So we go ahead and substitute our numbers into the equation. We get y equals 10,850 times the quantity of 1 plus 0.05 to the 13th power. Following our order of operations, we got to do what's inside parentheses first, so we add those together to get 1.05. Next we have to do exponents, so 1.05 to the 13th power is 1.885649142, and then multiplying those two numbers we get $20,459.29. We're dealing with money, so you want to round it to the hundred spot because that's where we have our cents. Alright, moving on to example 2. The population in Richfield has been decreasing by an average rate of about 0.3% per year. In 2000, the population was 34,439. Write an equation to represent the population since 2000 and predict the population for this year. This problem, we are working with exponential decay. It's exponential because we've got a percentage, and we know we are decaying because we are decreasing. So we're going to use the formula a times the quantity of 1 minus r to the t. Again, let's define what our variables are. A is the amount, in this case it's the population of 34,439. R is the rate of 0.3%. As we change this into a decimal, it becomes 0.003. And t, again, subtracting our year minus the 2000, we have been working with this population for 13 years. Alright, filling the numbers into our equation, this is what we have. Doing our parentheses first, we get 0.997. Then we do our exponents of 0.997 to the 13th power. Then we multiply those numbers together and we get 33,119.79122. Now this is talking about population, and so we need to round to the nearest whole person. So we're going to round this to 33,120 people. Alright, example 3. If you are going to invest $300 that you just got for your birthday at an interest rate of 3.5%, compounded monthly for 22 years, how much money would you have? Well, in this particular problem we're working with compound interest, and it will always say compounded. So we're going to use the formula a equals p times the quantity of 1 plus r divided by n to the power of nt. Alright, defining our variables, P is our principal, our starting amount. In this case it's our $300 we are starting with. The R is the rate, 3.5%. Turning that into a decimal is 0.035. N, the number of times compounded per year. It says it's compounded, let me get my highlighter here. It says it's compounded monthly. And monthly means that it's going to happen once a month. So that's going to be 12 times because there's 12 months in the year. So it's going to be compounded with the number 12 for our N. And T is the number of years, which it says 22 years. So as we substitute these numbers into the equation, we get A equals 300 times the quantity of 1 plus 0.035 divided by 12 to the 12 times 22. So just replacing all of the numbers that we just defined with the variables in the equation or the formula. Alright, inside the parentheses we've got adding and dividing, so we have to do our dividing first. 0.035, I should take that back. Let's figure out what our exponent is. 12 times 22 is 264, and I guess we could have started with 30.035 divided by 12, which gives us this long decimal. Then we need to add together the decimals in the parentheses. Now we got to do our exponents of the 1.0029 to the 264th power, and we get 2.157347078 times 300, and we're working with money, so we get $647.20. Alright, so these are the real-world formulas on exponential growth, exponential decay, and compound interest, which are all used frequently in the real world.